Out of Cal folks, Mr. Norman here. So I'm going to go over the member maths assignment that we were doing Friday. So write the name of each decimal place as indicated. So we're just going to go to this chart in case you don't remember. Look up place value. So if we look at this chart, we start at the ones. Here's the decimal. It goes 10th, 100th, 1,000th, 10,000th, 100,000th, millionth, and it keeps going. It's the same stuff in both directions. So let's see where we were. So that's 10th, 100th. So now if we look at number 2, it's the same type of problem. So if this was the 100th, then this is the 1,000th, and this is the 10,000th. So now we're going to round. So if this is what's underlined, we're going to look at the one behind it. So if we have the number behind it, it's 5 or more, we add 1. So 9 plus 1 is 10. So this 1 gets added to the 8. 8 plus 1 is 9. 9 plus 1 is 0. And we're done. This is our answer. Next, we're going to evaluate our expression. We're going to use a little PEMDAS, order of operations. So we're going to please excuse my dear Aunt Sally. And we do please excuse my dear Aunt Sally. All this stuff is adding and subtracting, so we're just going to do it left from right. So negative 8 minus a negative 3. 8, 9, 10, 11. We add them together. Then we still have minus the negative 6. When we have two negatives next to each other, that turns this into just addition. So negative 11 plus 6 are rules for integers. When there's two different signs, this one's negative, this one's positive, we subtract and take the sign of the larger number. 11 minus 6 is 5. The larger number is 11, so it's a negative 11. So now we're going to follow order operations again. 5 plus 1 is 6. 6 minus 5 is 1. Pretty straightforward. This time we have a fraction. Whenever you add or subtract with fractions, you have to make sure your denominator or bottom numbers are the same. So I'm going to scroll down to some scratch paper and we're going to work it out. So now we need the denominators or bottoms to be the same. And to do that, we can multiply or divide. What number can 5 and 6 both turn into? That's 30. So we're going to multiply the bottom by 6 to make 30. Whatever we do the bottom, we have to do the top. So now we have negative 6 over 30. To make 6 and a 30, we multiply it by 5. When we do the bottom, we have to do the top. So now we have 30 and 25. This negative part can be a little confusing. So a neat little trick. If you have a minus in the middle, you can turn it into plus a negative. So now we have negative 6 minus plus a negative 25. So 6 plus a negative 25. The bottoms are the same. So it's still over 30. So now negative 6, negative 25, we add them. That makes 31. It's still negative over 30. In this class, we're almost always going to want the improper fraction, not a mixed number. So we are okay with it being a fraction. We don't need to make this 1 and 1 over 30. So this is our answer. So now we have 2 plus negative 4 over 3. Again, we're doing addition, and there's a fraction. We need to make this whole number to a fraction. To do that, we put it over 1. Again, we need the bottoms to be the same. We need a number that 1 and 3 can both turn into. We can turn 1 into 3 by multiplying by 3. What we ever do at the bottom, we do at the top. So now we have 6 over 3 plus a negative 4 over 3. The bottoms are the same, so we just need to look at the tops. 6 plus a negative 4 over 3. And 6 minus 4 is 2 thirds. Answer. So for the next two questions, we're just doing integer multiplication. Integer just means positive and negative numbers. So I made Mr. Sleepy Guy. Some of you may remember. He's going to help us remember our integer rules. So 4 times negative 2, we have a positive times a negative, which gives us a negative. 4 times 2 is 8. These parentheses also mean multiplication. So it's negative 5 times negative 2. So we have a negative, and a negative will make it a positive. So it's 10. Next, we're going to find each quotient. Quotient is just the answer to a division problem. So we have 3/7 divided by 4. So to do this, first we need to turn the 4 into a fraction. Just put it over 1. So now we are going to keep, change, and flip. We're going to keep the 3/7. We're going to change the divisional multiplication. And we're going to flip the 4/1 to 1/4. And now we multiply. To multiply fractions, it's top times top and bottom times bottom. 3 times 1 is 3. 7 times 4 is 28. Done. So that's our next question. It's just another dividing fractions problem. So once again, we're going to keep, change, flip. So keep negative 1/4, change division multiplication, flip the fraction. So now we're going to multiply top times top and bottom times bottom. I'm going to point out that 8 and 4 have something in common, 4. So we can simplify before we multiply. And that will give us negative 1/1 times 2/5. Top times top is 2. Bottom times bottom is 5. I forgot the negative. That's the answer. If you don't see the simplification, it doesn't matter. 1 times 8 is 8. 5 times 4 is 20. We just have to simplify this and take 4 out of the top and bottom. And that gives us 2/5 negative. Same answer. More than one way to get to Houston, as long as you follow the roads. This next question is asking about GCF. That stands for greatest common factor. We're going to use a factor tree to solve this. I misspoke earlier. We're not going to use a factor tree. We're going to just see what the factors are. So we're going to look for the factors of 12. So factors are just the numbers that multiply to make 12. So we have 1 and 12, 2 and 6, 3 and 4. And then the next one would be 4 and 3. Once a number repeats, we know we're done. So these are all the factors of 12. In the future, if you're not sure how to do this, you can take your calculator and divide all of your numbers. Factors are always whole numbers. We can do the same thing for 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, 8 and 6. We are done. So the greatest common factor is just the largest number they have in common. So 12 is our biggest number, and we have 12. And that's it. The greatest common factor of 12 and 48 is 12. Next question, we're looking for the greatest common factor again. For now, we're going to ignore the x's or the variables. Same process as before. 1 and 35, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7 works, 7 and 5 works. We're done. 10, 1, 10, 2, 5, 5, 2. We're done. The largest number they have in common is 5. So this is the first part of our answer. Now for the variables, it's very straightforward. This one has 3. This one has 2. We're going to go with the 2. Bam. That's our greatest common factor of 35x cubed and 10x squared, 5x squared. The next question says to evaluate. So all that means is we're going to use our order of operations and combining like terms to get to an answer. PEMDAS, please excuse my dear Aunt Sally. The first thing we're going to do is multiply or divide. Or remember, notice how these parentheses. Remember that this is multiplication between the 3 and the parenthesis. Inside the parenthesis, we can't do anything because this is an x and that's not. So this is like subtracting apples from oranges. They have to be the same kind of number. So we're going to distribute, and all that means is we're going to multiply the 3 by everything on the inside. 3 times 2 is 6. The x comes along, minus 3 times 2 is 6. The plus comes, we have negative 1. We can only combine like terms. Our like terms are the things that don't have x's in them for now. So negative 1 minus 6 is negative 7. And the 6x just carries over, and boom, that's a simplified answer. Here's the next question. Again, we're going to follow our order of operations. Parentheses first. This is a variable or a letter. This is a number. We can't mix them apples to oranges. Next, we're going to multiply. So we're going to multiply this times negative 5. How do we do that? Same as we did before. We're just going to distribute it. Yup, you can do it from the behind or from the front. Fun times. So negative times a positive is a negative. K times 5 is a negative. So we have a negative 5k. A negative and a positive is a positive. 5 times 2 is 10. The 6 comes down. So again, we're just going to combine like terms. Numbers go with numbers, variables go with variables. So that is 16 minus 5k. Solve the equation. This one is a one-step problem, so we don't need to scroll down. 13 equals a divided by 6. We want the a by itself whenever it says solve. The opposite of divide by 6 is multiply by 6. So these cancel out. So we have a equals 13 times 6. 6 times 12 is 72, plus 6 is 78. No, it doesn't matter that the a was over here. Now it's over here. That's the answer. Hope that thunder wasn't too loud for y'all. Again, we're solving another equation. So that means to get the variable by itself. Oh, I forgot to tell you about inverse operations, or SADMAP. SADMAP. So if PEMDAS goes one way, we're going to do reverse operations, or the opposite direction, SADMAP, to solve our problems. So SADMAP, so we're going to do the opposite first. So we have a minus 9. The opposite of minus is plus. So what we do to one side, we have to do the other. So we have negative 5x equals 6 plus 9 is 5, carry the 1, which is 75. Next, we have divisional multiplication. Reminder that there's multiplication between the 5 and the x. So that means the opposite of this multiplication is going to be division. What we do to one side, we have to do the other. We have to make sure to bring that negative with us. So x equals negative 25. So once again, we're trying to get the letter by itself. So before we do our SADMAP, to isolate the variable, first we have to combine like terms on each side. These are both normal numbers, so we combine them. Negative 2 plus 7 is the same thing as 7 minus 2. So our new left side is 6k plus 5 equals, on the other side, we have k's. So 7k minus 3k is 4k, and it's a positive, and we have 11. So now we need to get all of the letters on one side and the numbers on the other. It doesn't matter which way you go. I'm going to move the 5 because that's what I'm feeling like doing right now. It doesn't matter which. So our new equation is 6k equals 6 plus 4k. The reason why I said equations have expression, equations have an equal sign, expressions do not. So now to move the k stuff, minus 4k, minus 4k. So 2k represent equals 6. Unfortunately, we don't want 2k, we just need k. So we're going to divide both sides by 2 because there's multiplication here. And k equals 3. Now for the penultimate question. Penultimate means second to last. Simplify the expression. Remember, when it says simplify, there's nothing to solve. There's no equation. Breathe. We got some exponent. It's not a big deal. We have two parentheses, order of operations. We're going to do parentheses first. We can't combine like terms. Next, we're going to multiply. Remember, there's an invisible 1 next to that negative. And between the negative, between the 1 and the parentheses, there's a multiplication. Which means all we got to do is distribute. So we're going to multiply both pieces by -1. So we have 4n squared plus 6 minus -1 times 5n squared is -5n squared. Negative times negative is a positive 6. Do we have any like terms? Yes, we do. These are both normal numbers. So that's 6 plus 6 is 12. This is n squared. This is n squared. We can combine 4n squared minus 5n squared is -1n squared. And boom, that's the answer to this. Last but not least, we're going to find each product. So we have this. Remember, when you square a number, that means it's the number or expression times itself. So there's two ways to solve this. Well, there's probably more than two ways, but there's two general ways that you've been taught to solve this. I'm going to do the box method first, and then I'm going to do double distribution. Oh, you've done 3 ways. I'll do 3 ways. Sorry. You can do the box method, you can FOIL, or you can double distribute. I'm going to do the box method first. You can fast forward if it's not your method, or if box method rings no bells. We're going to write what we got, and we're just going to multiply to fill each box. 5 times 5 is 25. A times A is A squared. 5 times 2 is 10. The A comes with it. 5 times 2 is 10. The A comes with it. 2 times 2 is 4. This diagonal, we're going to combine like terms. These are both 10A. They both have A's. It both works. 10 plus 10 is 20. The A comes with it. The 4 comes down. It's a positive. The 25A squared comes down. This was a positive 20A. We have our answer. So this is the box method. I don't know why it says loading. There's nothing down there. The next thing we're going to do is FOIL. So F stands for first. So these are the first numbers. And we're going to multiply them. 5A times 5A is 25A squared. The next we're going to do is outside. This is the outside. This is the outside. 5A times 2 is 10A. The next thing we're going to do is inner. This is the inner. 2 times 5 is 10A. And the last, L is last. Last 2 times 2 is 4. Yes, these should look similar. When you are driving to Houston, we combine like terms now. When you're on your way to Houston, it's going to look like Houston as you're getting there. That's our answer. These are the same. The last method is double distribution. So we're going to write 5A plus 2. 5A plus 2. Let me label this. So when we double distribute, we're going to use distribution twice. We're going to take this 5A and multiply it to both pieces. 5 times 5 is 25. A times A is A squared. Plus 5 times 2 is 10. The A comes with it. We're going to distribute the second piece. This is why it's called double. We're going to distribute twice. 5 times 2 is 10. The A comes with it. 2 times 2 is 4. We're going to combine like terms, and we have 25A squared plus 20A plus 4. Bing, bang, boom. All the answers are there. I hope the member maths wasn't too bad for you. I hope this rung some bells. Thank you very much if you managed to do this full 20 minutes. And peace.